Well, this chair was created in around 2010 with the joint support of Hydro-Québec and a National Research Council. And what this chair was able to do is develop a program that was rather unique in the sense that it allowed us to access the study of our surface waters in the boreal biome of Quebec, which was essentially very little studied at that point, mostly because of issues of accessibility and cost. So the other aspect that is quite relevant of this program is that we have not just studied either lakes or rivers or wetlands or reservoirs. What we have done is we have tried to integrate the ensemble of aquatic systems that exist in this landscape. It's a very complex network of aquatic ecosystems that have never been studied in its entirety. And this is what the chair has tried to do. And then to place the hydroelectric reservoirs within this aquatic network. So this has rendered our program rather unique, not only in Canada, but elsewhere in the world. And it has generated, I think, what is a very substantial and very robust scientific output, not only of fundamental science, but also science that is useful in terms of placing, for example, hydroelectric reservoirs within the context of the whole landscape carbon footprint, which is what we have been doing now for a while. We are privileged to be in an area that has enormous amounts of water. In particular, Quebec has one of the highest densities of freshwater, of surface waters in the world. And this is both a privilege and a big responsibility. And this is one of the things that have guided our research program. And this is also evident in hydroelectric development in Quebec because of the availability of these freshwater resources that we have. And there are other places in the world with high abundance of freshwater resources and of lakes, of rivers, and including tropical areas which have abundant freshwater resources. The processes that we look at, for example, the greenhouse gas, the processes that generate greenhouse gases are not different between tropical and subtropical areas, boreal and temperate areas. The processes themselves are not different, and we know them more or less. We and others have been studying them for a while. What changes is the magnitude of this process. So, for example, if we take methane, methane is not limited to any particular ecosystem. Methane is present in every single aquatic ecosystem in the world. It's just that the processes that generate methane or the processes that eliminate methane vary depending on where you are. And in this regard, for example, methane tends to be higher in places that are warmer, that tend to lack oxygen, that tend to be perhaps deeper and develop conditions that favor the production of methane. And in this sense, I think it is, I wouldn't say we are lucky, but it is a favorable aspect that our reservoirs in our boreal reservoirs collectively don't have those ecological conditions that tend to favor, for example, methane production. But this is just the ensemble of conditions that are naturally present, which are low temperature, long winters. They tend to be relatively shallow. They don't become anoxic. Other systems in other parts of the world function differently. The processes are the same. We understand the processes, except that the conditions vary between tropical areas that tend to be warmer, tend to be more stable, and so on, subtropical areas, and, for instance, our boreal areas here. And these are the topics of our research. We do research in the boreal, but we also do a lot of comparative research, where we compare the magnitude of these processes between our region here and regions in other places, including the processes related to hydroelectric greenhouse gas dynamics, which is an important aspect of our research. we have been working in La Romaine since 2014. The first reservoir, La Romaine 2, was flooded in 2015. Now we started to follow La Romaine 2 when it was first flooded, and we started to follow the river and the basin before the other reservoirs were flooded, because it is now common knowledge that, but it wasn't until recently, that in order to develop the carbon footprint of these reservoirs, you actually have to understand the landscape that was flooded before, the carbon footprint of the landscape that was flooded. Because the reservoir implies a change in carbon footprint. So in order to quantify that change, you need to be able to understand what was there before. So we were in this landscape, we were there before. We were measuring the carbon footprint of La Romaine River before it was impounded, of the rivers and lakes that were in the basin before they were impounded, and together with colleagues who we collaborate, we were studying the carbon footprint of the terrestrial portion of La Romaine that was impounded. All of this in order to calculate the footprint of each of the reservoirs. But the final objective of our program as well is to develop the carbon footprint of the complex, because each of these reservoirs has its own footprint, but here we are talking about a complex. It's one after the other. It's a rather complex thing. I'm repeating myself, but this footprint is complex because these reservoirs were created at different times. They have different ages. One reservoir influences the other. So the carbon footprint of a complex is not just the sum of the four footprints of each of the reservoirs. This has seldom been done, although there are quite a few examples in the world of reservoirs that have been created sequentially along a river. There are very few examples in the world of carbon footprints of entire complex of reservoirs that are in a chain along the river. So we want La Romaine, this study in particular, to be a case example, not for Quebec and for Hydro-Québec in this particular, this is one of the objectives, but in fact, to be a case example that can be used across the world as a way of actually doing this. So this is our long-term objective, and I think we are well on the way to achieving this objective. So our program has been quite large, as we had said before, and in order to carry out this large-scale program that included lakes, rivers, reservoirs across a very large landscape over all these years, it has taken a very large group, and we have been lucky to have the influx of excellent students and postdocs and many collaborators that have contributed to this. And it has also been an important training platform over the course of the years, which I think over 15 PhDs have trained in the chair program. I think at least the same number of master students and at least the same number of postdocs. Many of these people now have positions, academic positions in Canada and elsewhere in the world. So it has been an important platform for training, multidisciplinary training, because we have done quite a lot of different things. And but at the basis of this has been to put the water that is in a landscape on the table. The water in a landscape needs to be accounted for in regional models, needs to be taken care of. Whether it's natural water in our rivers and lakes or whether it's the water in our reservoirs. So I think our research has and will still contribute towards that, and positively, I think, because our research has been robust, I think, scientifically, and has been abundant in that sense. And it's not so much the number of papers, which account for at least 120, 130 papers in the last 10 years on this topic, but more important than the number of papers is the fact that these papers help to put the water that exists in the landscape and our reservoirs on the table of of the scientific table, but also on the table of the need to include this water in our regional carbon balances, to include our reservoirs in our national inventories. This is what our research is contributing towards, and I am proud of that.